guys, hope you're having a great time with e-learning. So today what we're going to do is finish up the last of the log and exponential review. And then that is due on Friday by 11:59 p.m. That's the only assignment for this week. And then next week we're going to start graphing. So what we're going to do is just 2 problems to finish off the bottom of the review. Again, you can always get on Zoom and ask any questions that you may have. So just quickly review from this week. We were having to do the same thing. Remember, the log form is log base b of x equals y. Exponential form is b to the y equals x. And important to know, especially when we start to solve, when we start to graph and do a bunch of things, that natural log is the same thing as log base e. So we'll flip-flop back and forth between those forms there. Okay. Today we're going to use a lot of the properties as well. So we didn't really use them much yesterday's video, but today we're going to. And we're going to be condensing. So we're going to be going from left to right. So remember that addition means multiplication. And when you condense, most of the time you drop a log. Most of the time, not 100% of the time. Subtraction means division, okay? And when you're multiplying a log by a number, that number then becomes the exponent of the term inside the log, okay? So you're going to be using those properties and switching back and forth between forms. So we're going to do 2 problems today. The first one we're going to do is this one right here. So it's log base 2 of x plus log base 2 of x minus 3 equals 2. So we talked yesterday about how you can cancel out logs, and it's a 1-to-1 ratio. But it's a 1-to-1 ratio on either side of the equal sign. So these 2 logs cannot cancel, okay? That's a habit that I'll see a lot of people try to do. Like, oh, this is so easy. Hold on, they can't cancel yet. So what I see, though, is addition. And addition means multiplication. So I'm going to condense this side of the equation. So when I do that, I get log base 2, and I'm going to distribute that x to both. So I get x squared minus 3x equals 2. So I get log base 2 of x squared minus 3x equals 2 because I distributed that x, I'm multiplying it. Okay. And I'm looking at this problem like, wow, there's an x squared there. It's probably going to have to do something with a quadratic, so I'm going to probably get 2 possible answers. They can be extraneous, 1, both, none. So I'm just thinking ahead. I'm going to be using a lot from quadratics unit from first semester. So again, I only have 1 log. So I'm going to only have 1 log. Really, the only thing to do here is to change the exponential form. So I'm going to do that. So I get 2 squared equals x squared minus 3x. Okay? So 2 squared equals x squared minus 3x. And I'm going to move everything onto one side, and I know that 2 squared is 4. So when I get that, I'm going to end up with x squared minus 3x minus 4 equals 0. So I get x squared minus 3x minus 4 equals 0. Then I can try to factor this. Or I can try to solve it by quadratic formula. Or completing the square. There's a bunch of different methods I could use here. I'm going to do factoring because I'm more comfortable with factoring. But you do whatever's best for you. And I look at this problem and say, okay, this factors to x minus 4, x plus 1 equals 0. So I get x minus 4, x plus 1. And remember, if I distribute this back through, I should get back to this quadratic. And if I don't, that's like a little sign to me going off that I must have done something wrong when I was factoring it. So from here, which is funny, I'm doing this in Algebra 1 as well, I'm going to use a zero product property rule to solve each one of these binomials, okay? So I end up with x equals 4 and x equals negative 1. So I set those equal to 0. However, I have to check them in the original problem and make sure they work. And remember that I said you can never do the log of a negative. So right away, I know this negative 1 is not going to work. Negatives can work if I plug it in, it becomes positive. But when I plug in a negative 1 here for the x, it stays negative, and I can't do that. Okay, unless there's a reflection or something, which we'll talk about with graphing. So my only answer here would be x equals 4. Okay? So that's what you do when you have 2 logs on one side, or if you have 3 logs on one side, you're just going to work on condense, 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 and then you're going to have to change the forms. But some of you are probably saying, okay, lever check. But what happens when there's multiple logs and there's logs on either side? What can I do then to make it a little bit easier? Well, let's do that problem. So here I have log base 3 of x plus log base 3 of 6 equals log base 3 of 12. That's a lot of logs going on. Again, it's a 1-to-1 cancelization. However, you don't want to do that yet. You want to condense the one side until you have 1 log on either side to then cancel, okay? So again, I have addition, and we know that because of our properties, addition means multiplication. So right away, I'm going to condense the left side, and I end up with log base 3 of 6x equals log base 3 of 12. So addition means multiplication, so I just put together the 6 and the x. What's nice about this problem is I now have one log on either side. So instead of having to change forms to exponential, those logs are just going to cancel out. So what I'm left with is a basic linear problem. So I end up with 6x equals 12, and so x equals 2. And when I plug that in, it does work, okay? So even though you might see multiple logs on a problem, don't freak out, condense, 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 until you have one log on either side, and then solve the problem, okay? Again, if you guys have any questions whatsoever or anything on the review, please log on to Zoom, and I'll answer those questions. The assignment is due Friday by 11:59, and then enjoy the weekend, and then on Monday, we're gonna start back with graphing. So I hope you have a great day. I hope to see you on Zoom, and talk to you guys later. See you guys.